It was called the National Advisory Committee for Aeronautics, a new independent agency created by President Woodrow Wilson in 1915. Its job, make the United States a world leader in the field of aeronautics. In less than 3 decades, these early pioneers in aviation and those who followed would be called upon to think through problems a million miles away and do it with boldness and vision. By the mid-1950s, NACA had modern wind tunnels and was moving into the area of rocket and satellite research. Then on October 7, 1957, the U.S. and the rest of the world were greeted by the sounds of Sputnik 1. The Soviet Union had placed the first artificial satellite into orbit. It would not be until early the following year that America's satellite, Explorer 1, successfully orbited the Earth and discovered a dense belt of radiation surrounding our planet. Who would have believed at this early stage that we would one day move outward from the thin ribbon of Earth's atmosphere to the very edge of our solar system and beyond? Project Mercury, the country's first manned spaceflight program, was given the go-ahead just 1 week after NASA was formed on October 1st, 1958. Seven test pilots were selected to become astronauts. Donald K. Deke Slayton, Alan B. Shepard, Walter M. Schirra, Virgil I. Gus Grissom, John H. Glenn, Jr., Leroy Gordon Cooper, and Malcolm Scott Carpenter. The 7 new astronauts spent months and months undergoing rigorous testing and training. While they were being trained, several monkeys took check rides in the new Mercury spacecraft. Meanwhile, the orbiting of unmanned satellites became more and more commonplace, and weather watchers like Tyros found a permanent place in our daily lives by improving weather forecasting capabilities. On August 12, 1960, President Eisenhower took part in the first transmission of the Echo 1 communications satellite.
This is President Eisenhower speaking. It is a great personal satisfaction to participate in this first experiment in communications involving the use of the satellite balloon known as Echo.
On May 5, 1961, astronaut Alan B. Shepard made America's first suborbital flight. Project Mercury was underway.
2, 1, 0.
All right, lift off and the clock has started. Yes, sir, reading you loud and clear. This This is Freedom 7. The fuel is go, 1.2 G. Cabin at 14 PSI. Oxygen is go. Cabin pressure is holding at 5.5.
Soon after Freedom 7 landed, President John Kennedy gave NASA an ambitious new space goal.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win, and the others too.
After Alan Shepard and Gus Grissom's test flights, 4 other American astronauts orbited the Earth in Mercury spacecraft, starting with John Glenn. He was followed by Scott Carpenter, Wally Schirra, and Gordon Cooper.
You are go. Water systems, go. Range operations, Mercury capsule, go. All pre-start panel lights are correct. The ready light is on. Eject Mercury umbilical. Oil evacuate. Mercury umbilical clear. Mercury evacuate. Lights on. All recorders too fast. T-minus 18 seconds and counting engine start.
May the wee ones be with you, Thomas.
8, 7.
As NASA geared up to respond to the lunar commitment, it became clear that new management techniques for handling far-flung systems manufacture and final integration would have to be developed. Clear also was the fact that state-of-the-art electronics and computers would be pushed to the limit. Unknowns about the moon were numerous. Such things as whether an astronaut would sink into dust over his head were a real concern. Lunar impact studies like these were carried out in an attempt to learn. Researchers fired projectiles simulating meteors hitting the moon into sand-like and rocky materials, and then measured how much material was thrown out by the impact. This animation shows how scientists believed the huge crater Tycho was formed on the moon, a crater 54 miles wide. A series of picture-taking Ranger spacecraft slammed into the moon. Then, 5 lunar orbiters photographed over 90% of the moon's surface, including the never-before-seen backside. We saw a glimpse, too, of our own planet from lunar distance. But most important of all, it made possible the selection of landing sites. Six Surveyor spacecraft made soft landings on the moon over a 2-year period. A robot arm dug a trench. Lunar soil was like wet sand. Men and equipment could safely land there. Panoramic views like these were assembled from hundreds of individual photographs. Communications via satellite exploded into a whole new industry. That first live intercontinental transmission by Telstar 1 was just the start.
La chansonnette après l'effet du...
Relay, designed to transmit television, telephone, and high-speed data. Syncom, with Olympic coverage from Tokyo, and Early Bird 1, all were follow-ons to previous research and development.
5, 4, 3, 2, 1, take it! Hold on!
Because of the following special one-hour broadcast, programs previously scheduled at this time will not be seen.
Since rendezvous, docking, and having astronauts work outside the spacecraft were critical to lunar missions, NASA began Project Gemini. Using the Mercury capsule as a model, the Gemini spacecraft was enlarged to hold a two-man crew. Gemini would provide design answers for the upcoming Project Apollo. And who could ever forget that spectacular first walk in space made by astronaut Ed White? Ten times pairs of astronauts flew into orbit, walking in space, rendezvousing, and docking. Gemini had blazed a trail for Project Apollo, the three-man spacecraft that would carry astronauts to the moon. More than 8 years were poured into designing, building, testing, and preparing astronauts, rockets, and spacecraft for the first lunar landing. Here's a visual look back at some of that preparation. In 1967, tragedy struck. The nation mourned the loss of the crew that would have flown the Apollo spacecraft on its maiden voyage. Astronauts Gus Grissom, Ed White, and Roger Chaffee died in a flash fire as they were conducting pre-flight tests on the launch pad. The manned flight schedule was delayed 18 months as the command module underwent redesign. While these changes were being made, the parts and pieces needed to assemble the giant Saturn V moon rocket came together at the Kennedy Space Center, Florida. Everything associated with the Saturn V was huge. The rocket itself, the building where it was assembled, and the crawler transporter that carried it to the launch pad. The fully loaded Apollo Saturn V was 363 feet tall. Its main engines alone generated 160 million horsepower, and its fuel pumps pushed fuel to the engines with the force of 30 diesel locomotives. As Saturn V lifted off Launch Complex 39 for the first time, it weighed more than 2,800 tons. The pace quickened. Starting with Apollo 8, every Saturn V launched had a three-man crew. Two days before Christmas in 1968, astronauts Borman, Lovell, and Anders became the first humans to pass out of Earth's gravitational control and into that of another body in the solar system, the Moon. The hardware to travel to the Moon had worked well, and landing sites looked good. Our Earth seemed small and fragile, hanging in the vastness of space. This view of ourselves from lunar distance would change the way we think about Earth for all time. It raised profound questions, especially those associated with the Earth's finiteness and unlimited resources. The next two flights, Apollos 9 and 10, would continue dress rehearsals for the first lunar landing. All systems were indeed ready. Astronauts Neil Armstrong, Edwin Aldrin, and Michael Collins would make the historic journey. Next stop, Tranquility Base.
2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11. Tower cleared.
We got a roll program.
Neil Armstrong reporting the roll and pitch program, which puts Apollo 11 on a proper heading.
Houston, Apollo 11 is calling you on the high gain. How do you read, over?
Roger, loud and clear on the high gain.
Eagle, you're looking great. Coming up 9 minutes.
We're now in the approach phase, everything looking good. Altitude 4,200.
Houston, you're a go for landing, over. 40 feet down, 2.5. Picking up some dust. 30 feet, 2.5 down. Straight shadow. 4 forward. 4 forward, drift into the right a little. 20, down a half. 30 seconds. Forward, just. Good. Hey. Contact light. Tranquility Base here. The Eagle has landed. That's one small step for man, one giant leap for mankind.
Across the country and around the world, the Apollo 11 crew were welcomed back as heroes. Meanwhile, more than 100 scientists from here and abroad began intensive studies of the lunar samples. Before Project Apollo ended, 6 additional flights to the moon were made, and all but one were highly successful. Skylab was the next manned spaceflight. Launched first was a 2-story orbital workshop. Then the first of 3 3-man crews departed to meet, join, and begin living in the orbiting laboratory. Those crews would stay 28, 59, and 84 days respectively. One of the major objectives was to find out if astronauts could physically withstand extended stays in space and continue to do useful work there. The answer was a resounding yes. Experiments in astronomy, Earth resources observations, materials processing, and crystal growth all proved highly successful. Then ASTP, Apollo-Soyuz Test Project, a joint endeavor between the Soviet Union and the United States. The mission called for a mutual docking and crew exchange to develop the necessary equipment for international space rescues. Before, during, and after Apollo, Skylab, and ASTP, NASA's unmanned planetary programs were giving scientists exciting new glimpses into the history of the solar system, from early explorers to the infrared astronomy satellite. 7 Mariner spacecraft flew by the planets Mars, Venus, and Mercury, sending back a stream of pictures and data. 10 Pioneer spacecraft did likewise, including Jupiter flybys and probes through the atmosphere of Venus. Pioneer 10 became the first man-made object to leave the solar system. Atmosphere physics, astronomy, meteorology, and geodesy. These are just a few of the scientific disciplines studied by dozens of Explorer-class orbiters through the years. Hundreds of sounding rockets have probed the atmosphere above where balloons are effective, but below the area that satellites fly. Biosatellite was sent aloft to answer basic biological questions. Will cells divide normally while weightless? How does zero-G affect plant growth? Would radiation and weightlessness be a hazard on long-duration space flights? Everything from plants to primates were orbited aboard biosatellite to find out. There were the OGOs, orbiting geophysical observatories that blossomed out like giant dragonflies in space. OSO, orbiting solar observatories, studied our sun and its influence on Earth. In the last 25 years, our orbiting astronomical observatories have radically changed our view of the universe. We now see a dynamic universe of quasars and black holes and other extraordinary objects, of cataclysmic forces causing the birth and death of stars, of billions of galaxies wheeling in the immensity of space. We looked back at planet Earth with Landsat remote sensing satellites. Crops, forests, pollution, all can be photographed in great detail to help us better manage our Earth's resources. The Viking program was a systematic effort to investigate the planet Mars. 2 separately launched Viking spacecraft, made up of a pair of orbiters that would photograph from above the planet, and twin landers built to descend to the Martian surface, spent 11 months and 420 million miles traveling to the mysterious red planet. The lander's robot arm conducted chemical and biological tests on the soil in a search for life forms. Martian weather and seismic reports were also sent back routinely. Cameras began returning pictures, thousands of pictures. Color photographs showed a surface littered with rocks. A fine dust, red or yellow-brown, could be seen everywhere. We even had a chance to view the 2 moons of Mars, Phobos and Deimos. Viking's complex science and technology were considered to be a triumph equal to the landings on the moon. Two unmanned Voyager spacecraft carried a record with the sights and sounds of Earth, just in case they encounter a cosmic neighbor along the way. Their interplanetary journey was designed to take them past Jupiter and Saturn, and eventually one Voyager was to pass close to Uranus and Neptune. Voyager sensors recorded Jupiter's intricate weather patterns and detected massive lightning bolts in its churning cloud tops. It took 40 minutes for a signal from Voyager passing Jupiter to be received by mission controllers at the Jet Propulsion Laboratory, so the spacecraft had to be essentially automatic. Voyager also took a good look at Jupiter's largest moons. There's Io with its active volcanoes. Europa. Ganymede, the largest moon, appears to be a mixture of rock and ice. And Callisto, probably the oldest of the 4. The Voyager's next assignment was to fly by Saturn and its moons. Saturn's vast ring system is made up of many small particles that orbit the huge planet in wave-like patterns. Its atmosphere is buffeted by a strong jet stream that blows eastward at 1,200 miles per hour. Voyager detected the hottest gases ever observed in the solar system, up to 1 billion degrees Fahrenheit. As of now, 2/3 of the planets in our solar system have been explored, and by the end of this decade, we will have explored most of the rest, including Uranus and Neptune. Through the years, the single most constant in NASA has been, is now, and continues to be its aeronautical research. It is a common thread that is woven throughout the agency. It has influenced everything that flies, both on Earth and in space. There is little doubt why this country has been the world leader in things aeronautical. Here are some of the goals of the program. Make aircraft more energy efficient. Fly higher, faster, and farther on less fuel. Lower pollution. Systematic improvement of engine components. Reduce weight through use of light but very strong composite materials. Study problems associated with wake vortices, tornado-like patterns of air that trail off behind jet aircraft, causing problems for smaller planes following closely in their wake. Airplanes are America's leading industrial export, thanks to NASA's research and development programs. Since there are some 200,000 general aviation aircraft in this country, NASA research is also improving this class of airplanes. Crashworthiness and stall spin studies are good examples. The problem of potentially crippling ice formation is also being worked on. The heart of this research is a unique refrigerated test tunnel capable of simulating the icing conditions an aircraft is likely to encounter. Once a test has been run, newly developed computer codes are used to evaluate the results. During the early days of manned spaceflight, consideration was given to using a parawing to return astronauts and spacecraft to Earth. While this method was ultimately discarded, it did produce a rather interesting new sport. There has been extensive work done on planes that take off and land vertically. Ones that need very short runways. Hybrids that are combinations of airplane and helicopter. And oblique wing craft that reduce air drag by pivoting the wing at various angles to the plane's fuselage. The expertise used to make airplane propellers better has also been applied to powerful wind turbine electric generators, including some of the largest in the world. NASA's aeronautical research was the seed from which the space program would grow. A prime example of this was the lifting body project that began in the early 60s. The combination of wind tunnel tests and actual flights led to the design of the reusable space shuttle. When the design and wind tunnel work was complete, a series of approach and landing tests were scheduled. Since the orbiter has no power for landing, its ability to land easily with only one try was critical.
Gears coming. Steering gear coming. Gears down. 40 feet. 20 feet. 10 feet. 5 feet. 4 feet. 2 feet. 1 foot. Down.
The Enterprise's near-perfect landings gave final proof that the shuttle orbiter was a flyable, landable craft. The years of research and development would now be put to the ultimate test, the first flight into space of Shuttle Columbia with astronauts at the controls. There was an air of excitement as the brand new shuttle moved from its processing facility at the Kennedy Space Center to the vehicle assembly building, where it would be mated with rockets and fuel tank and rolled out to the launch pad. Never before had a new spacecraft been flown this way. Previous Mercury, Gemini, and Apollos were man-rated in advance, meaning that unmanned flights were flown before putting an astronaut crew on board. Despite nagging problems with engines and protective tiles, there was a quiet optimism. Longtime space workers knew from past experience with the lunar landing program that design and engineering problems do get worked out. After one false start, astronauts John Young and Robert Crippen headed for the launch pad.
Seconds. That goes into the interior, and the astronauts are
Columbia's maiden flight would be brief, just 54 and a half hours, 36 orbits, and return to Earth. But it signaled the beginning of a reusable space transportation system.
Checking to ensure that everything is in the proper place.
Minus 10, 9, 8, 7, 6, 5, 4. We've gone for main engine start. We have main engine start.
Roger, Columbia. You've got your normal Capcoms back now.
Okay. Well, the only bad part about it, Joe, is we're going to have to come down. Three, two, one, down. 5, 4, 3, down.
Look at the sand! Look at the sand!
30 weeks later, after Columbia had been returned to the Kennedy Space Center, cleaned, refurbished, and rolled out to the pad, astronauts Joe Engle and Dick Truly flew Columbia into space again. While an imaging radar system mapped distant Earth, the crew made a critical test of a Canadian-developed mechanical arm that would later place payloads into and out of orbit.
Okay, we copy. Thank you.
Looks like it's a little cloudy out here, Sally. It's a good thing the Sir AC's did that. And we can hear it crank up on board.
Okay, stand by. Okay, we see fan A on, and we'd like you to take broad.
As Columbia landed the second time, the circle was complete. A new generation of space travel had begun. When Space Shuttle 3 left the launch pad, it carried an experiment prepared by 18-year-old Todd Nelson of Rose Creek, Minnesota. An experiment to study the effects of weightlessness on insects in space. It's called the Shuttle Student Involvement Project and includes NASA, the National Science Teachers Association, and industry sponsors who help transform winning proposals into flight experiments. Since this first flight, young people in high schools around the country have developed and flown a variety of experiments, ranging from medical projects to the study of zero gravity on an ant colony. They are setting an example for others who may be encouraged to pursue careers in science and engineering, something that ultimately can be translated into technological leadership for the U.S. 12 weeks passed. Then, astronauts Ken Mattingly and Henry Hartsfield piloted Columbia on its fourth and final test flight. The spacecraft's performance made it possible to certify the Space Transportation System a fully operational carrier. As they landed on July 4th, the crew was greeted by President and Mrs. Reagan. Space Shuttle 5, the first operational flight. 2 commercial communications satellites were hauled into orbit, one for satellite business systems and one for Telesat of Canada. Their deployment was a complete success.
If you got it, you don't have it, obviously.
I got it.
Space Shuttle 6 was the second operational mission and Flight 1 for Challenger, this country's newest spacecraft. After launching a 5,000-pound tracking and data relay satellite from the payload bay, mission specialist astronauts Story Musgrave and Donald Peterson became the first Americans in 9 years to walk in space. Practice needed for satellite repair work.
Due for my massive article, rotate around and get it on the right side.
Story?
Yeah.
Tape caddy up here where it says tape on the left-hand door.
Yeah.
Mission 7 carried a crew of 5 into space, including America's first woman astronaut, Sally Ride.
For main engine start, we have main engine start and ignition and liftoff. Liftoff of STS-7 and America's first woman astronaut. And the shuttle has cleared the tower.
Roger, low, Johnson. Houston, now control confirmed roll maneuver starting.
She and mission specialists John Fabian and Norm Thagard deployed a pair of communication satellites for Canada and Indonesia.
Think that colors look good.
Roger that, looks great.
Shuttles 1 and 2 were now operational. With the addition of a third orbiter, Discoverer, to the fleet, and with literally dozens of astronauts in training at any given time, this new space transportation system would begin delivering in earnest and with increasing frequency. Opening a new era in science is Space Lab, where scientists from around the world work together in a unique international research center aboard NASA's Space Shuttle. Built by the European Space Agency, Space Lab is creating exciting new opportunities for research in all the sciences and is making routine international cooperation a reality. Looking farther ahead, there's the Space Telescope that will expand our vision almost to the edge of the universe. The shuttle gives the United States an unrivaled tool for the practical use of space. Historically, the space program has proceeded in a building block fashion, and toward that end, NASA has begun looking at the next logical step, a possible future space station, a permanent presence in space. The station would serve as a scientific and technological laboratory, as well as an operations base from which satellites could be serviced and large structures assembled. One of the highest priorities is to develop a clear understanding of a station's proper role in the total space program, so that if and when it is proposed for development, the station will be a truly significant national asset, one that would ensure continued American preeminence in space.
The space program in general and the shuttle program in particular have gone a long way to help our country recapture its spirit of vitality and confidence. The pioneer spirit still flourishes in America. In the future, as in the past, our freedom, independence, and national well-being will be tied to new achievements, new discoveries, and pushing back new frontiers. We must look aggressively to the future by demonstrating the potential of the shuttle and establishing a more permanent presence in space.